Hi, so today I'm going to be going over space coordinates and vectors in space. So first of all, we need to know that the z-axis is perpendicular to the xy plane. So it's going to look something like this. One second. Okay. So this would be the y-axis, x-axis, and the z. So you can tell that z is orthogonal to the xy plane. So if you were to look at this example, in order to determine what this point is over here, the blue point, you would kind of have to draw a shape. So you can tell that it's 2 in the x direction. You can go here. You can tell that it's 3 in the y direction. And then upwards, 4 over there, which is 4. So this point would be 2, 3, 4. All right? So now we're going to be trying to find the distance between points. So we have 2 points and we're trying to find the distance between them in the x, y, z. So it's pretty much exactly like in 2 dimensions where you just have x and y, but you're just adding one more dimension. So we know that the distance between 2 points in the x and y is just going to be x2 minus x1 squared plus y2 minus y1 squared. That would just be the distance of 2 points in a 2-dimensional space. So now that we're adding the z component, it's 3 dimensions. You can pretty much just add the z over here. So it's going to be z2 minus z1 squared. Exactly the same, nothing much changed except that you're adding the z at the end over here. Okay, so in this example, we're going to be finding the distance between points 2, negative 1, 3, and 1, 0, negative 2, okay? So using this equation over here, we're just going to pretty much plug in the values. So let's write them down, okay? We have x, y, z. So we can make these our x2, y2, z2, okay? So 2, negative 1, 3. And we're going to have x1, y1, and z1 over here. It's going to be 1, 0, and negative 2 over here, which is these values over here. So x, y, and z. So we're just going to plug that into the formula, which we're going to get. Okay. Here, plug in x2 first, which is right here. Okay. So it's going to be 2 minus 1 over here. And then we're going to get, whoa, don't forget to square this. That's important, okay? Plus y2, which is here, minus the 0. So it's just going to stay as negative 1 squared, okay? Negative 1 squared plus 3, which is over here, minus, so we have a minus 2 over here. So 3 minus minus 2 is just going to turn to plus 2 squared, okay? Equals, just quickly add this up. 2 minus 1 squared is 1 squared plus negative 1 squared is, wait, okay. Yeah, 1 squared plus 1 squared plus 5 squared. So it's going to be 1 plus 1 plus 25 equals square root of 27. And you can leave it like that. You don't need to simplify. So this is going to be our answer for this example. Okay, so the definition of a sphere. So a sphere of radius r and center x naught, y naught, z naught is represented by the standard equation of a sphere, which is this right here. It's going to be r squared equals x minus x naught squared plus y minus y naught squared plus z minus z naught squared, okay? And then here, the midpoint of the line segment joining x1, y1, z1, and x2, y2, z2. So if you were to have a line over here in the plane, let's say this is point A and point B. Here, let me draw that better. So we're going to have point there and let's say a point there. So what we're trying to find for the midpoint is right there. Okay? So the midpoint between these 2 points is going to be, okay, again, this is exactly like in 2 dimensions, but you're just adding the z at the end. So it's going to be x1 plus x2 over 2, comma, y1 plus y2 over 2, comma, z1 plus z2 over 2. Okay, so as you can tell over here, so if you looked at this part only, you can tell that that was the equation we use in 2 dimensions for finding the midpoint in 2 dimensions. So now it's exactly the same, just adding the z right over here. Okay. So for this example, it says find the standard equation of the sphere that has the points 5, minus 2, 3, and 0, 4, minus 3 as endpoints of a diameter. Okay, so first what you want to do is kind of draw this out like in a way so you can know what you're doing here, okay? So you have a sphere, okay? Okay, that's just like a good visualization, okay? So first, for the radius, you have to take the distance between both these points and then divide it by 2, okay? That's how you're going to get the radius, which is technically the midpoint. So here we can start off here. 2r equals square root of here 5. Keep in mind this 5 is coming from there. 5 minus 0 squared plus minus 2 minus 4, which is minus 2 minus 4 squared plus 3 plus 3. Here we got a negative 3 here, so you're subtracting 3 minus negative 3, which is just going to become a plus 3, okay? And don't forget to square that. You're going to have 2r equals square root of 25 plus 36. And then again here it's plus 6 squared, which is 36. So you can add all these up. It's going to turn out to 97. Okay, so this is 2r, don't forget that. So r equals square root 97 all over 2. Okay, so for the center over here, what we can do is, oh yeah, for the center, what you want to do is get the midpoint of these 2 different points in the plane. So what you're going to do is 5 plus 0 over 2, comma, minus 2 plus 4 over 2, comma, 3 plus minus 3 over 2. So we're just going to simplify this. It's going to be 5 over 2, 2 over 2, and then this is just going to be 0 over 2. It's going to turn out to 5 over 2, 1, 0. Okay? So now we have this information. over here, which is the center or the midpoint, and we have r. Okay, so we know r squared here. So going back to this formula up here, we're going to be using this one, okay? So we have r over here, which is rad 97 over 2. Here, let me write it out, one sec. Okay, so r squared equals x minus x naught squared plus y minus y naught squared plus... Okay, so r squared, which is rad 97 over 2 squared, equals... here, what you're going to do is x minus x naught, which is here. Okay, so minus 5 over 2 squared plus y minus the 1 over here squared plus z minus 0. The 0 comes from here. You can just keep the 0 out. Minus z squared. To simplify that even further, you can do 97 over 4. And then you can just keep the rest pretty much how it was. X minus 5 over 2 squared plus minus 1 squared plus z squared. So this right here would be our final answer. Okay. So here, these are some vectors that you should keep in mind. So the 0 vector would be just 0, 0, 0. The I vector, which is basically like this. Let me draw it out. Okay. So the I vector, keeping in mind this is y, z, and x. I is in the x direction, j is in the y direction, and k is in the z direction over here.